Okay, so as you might have seen by the title of this talk on meetup.com or wherever you learned about this, we're going to be talking about continuous verification today with the exciting subtitle of Beyond Chaos Engineering, as this is a step further than just your basic chaos engineering. So yes, we already did bios, but I'm Heidi. As mentioned, I've done some Java backend stuff, mostly with Kafka. That's my main area of interest, with highly transactional systems and systems that have a lot of spiky traffic patterns and interesting stuff like that. So that's me.
Yes, and I'm Kat, and I don't do useful stuff like Heidi, so that's me. Yes, so first we're going to go beyond chaos engineering. That means we have to first know what chaos engineering is, I believe. I'm just going to go through that quickly because I think some of you probably are already familiar with this. But chaos engineering, according to the principles of chaos.org, which is the kind of the website with the canonical definition and all that kind of stuff. Chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. So I'm sure there's a good set of practices around chaos engineering. There's a good set of tools around chaos engineering, so I won't go into like a great amount of detail here. If you are completely unfamiliar with chaos engineering and how it started and all of that, check out principlesofchaos.org. But it is generally, people talk about it starting at Netflix, where being like highly available, highly reliable was really critical. And so there was a push to kind of perturb the system and make sure that customers still had a good time. So that's kind of how chaos engineering was born. Yes. So now we know what chaos engineering is. What is continuous verification? So in chaos engineering, we perform some action and we ask, is this action safe? Is it safe to do this? Is it safe to fail this instance? Or is it safe to whatever, kill this pod? Is this safe? And in continuous verification, what we ask, and we keep asking, that's the continuous part, we ask what is safe? So we're trying to approach the boundary of safety for our systems, but we're not looking to cross that boundary. We're just looking to identify the boundary and then look to see how it's shifting over time or if it's shifting over time. So chaos engineering, we're saying, is this safe? And continuous verification, we're asking what is safe? And we just keep asking that. So that's kind of the distinction there between chaos engineering and continuous verification. So what I think I would expect to see is that organizations would first need to be properly instrumented to ask the question, is this safe, before they could start asking what is safe, because that requires a feedback loop so that you know when you're approaching the safety boundary, but that you don't violate it. So that's chaos engineering and continuous verification. Why is this an important thing right now? Well, because our systems are really, they're operating kind of at this peak efficiency when they're right at the edge of chaos, right? So there's all this pressure to operate in a way that's cheap. There's all of this pressure to operate in a way that like minimizes our effort. So we kind of push the systems, those two pressures. And right before we spill over into chaos, that's kind of really like the peak efficiency place for the system to be operating. So there is always that danger that we're going to kind of eat up our safety buffer and tip over into chaos. And as our systems become more and more complex and the set of interactions becomes more and more complex, we're right at the edge of that. And we could just tip right over the edge. So what we want to see is, where is the edge? And in continuous verification, we get really curious about what is the actual boundary of safety. Okay, and that I should mention, that's from Sidney Decker, who's kind of one of the leading people thinking about safety in all sorts of different systems, whether they're human systems or technical systems or socio-technical systems. So what is continuous verification? Let's go straight to the source, kind of the person who came up with this, QC Rosenthal. So he says that continuous verification is a discipline of proactive experimentation in software implemented as tooling that verifies system behaviors. So one of my pet peeves that I could rant about all day long is when people are just like, well, chaos engineering is more of like a mindset. Like you just like make peace with failure and then you're doing chaos engineering. And that is ludicrous. And that is just not at all accurate. You can't just like meditate and then suddenly you're doing chaos engineering and continuous verification. And with continuous verification specifically, you need tooling because of the continuous part, right? Like, can you do CI with no tooling of any sort? Whether they're tools that you make or you purchase, you need tooling. Tooling is part of that practice, right? Same thing with CD. So hot tip, if it has continuous in the name, you probably need tooling. And you can't just like go to a yoga retreat and come back and be continuous verification. So it is tooling that perturbs the system to approach the safety boundary, and then also has the feedback loops to back it off from that safety boundary. Yes, so that is the, I guess, for realty's definition of continuous verification. So why are we interested in this right now? Why is continuous verification starting to pop up as a thing right now, where we're at right now? So continuous verification is a tool for becoming sensitized to the safety boundary in a complex socio-technical ecosystem. And that's what's happening to us right now, right? Our systems have now become so large, individual humans can't understand them, right? They're very complex. The interactions are such that we can't always discern cause and effect until we're looking at it in hindsight. Right? So we are dealing with truly complex systems. So we have to become sensitized to when we're approaching that boundary, because we can't say like, for sure, these are the things that cause us to approach the boundary, right? Because a lot of times we can only tell the cause in retrospect. So when you're in the incident review meeting, you're like, oh, it's so obvious that change clearly caused these other things to also do this. And now here we are, and we have this incident, but it was not obvious in the moment. You couldn't detect that as it was happening. You could only detect it in retrospect. That's one of the attributes of complex systems. The behaviors are emergent, the system is acting on itself, all of these things, right? So now we have these big complex systems, and we need a mechanism for sensing the boundary of safety. I'm looking at the chat. Okay. Yes. All right. Okay. Yes. So this is the Agile Manifesto, right? Yes, all of us, we practice agility and we deliver working software frequently. So now we just had the anniversary of the Agile Manifesto. We've been doing this for 20 glorious years, working in an agile fashion, right? At least. And now we're so good at delivering working software, right? So good. What does it mean to keep that software working? As all the different components are changing constantly, and as user behavior is changing constantly, how do we continue? We're always delivering working software and we keep it working, right? So now we need a different set of tools to not just deliver working software, but to keep it all working together. So we have to develop these tools and this practice around understanding the behavior in production. Yes. And it is because we can have these beautiful test suites. We can be engaged in all of these practices to ensure that we are delivering high quality, and we still cannot, just by the nature and the scope of our systems, anticipate how they will behave in production until we see them in production. So there's this great quote from the Chaos Engineering book, which I highly recommend you read, has tons of actual real world examples of these things. So I think that is fantastic. Yes, but basically they say there is this thing that happens where engineers have these gaps of expectations around how their code will interact. And you can't possibly see all of those interactions in a non-production environment. You just have to have like 2 production environments, basically. And I think there's even an extra thing in there, which is that we can't anticipate how all of the pieces will interact, and we can't anticipate how the outside environment will interact with all those pieces. So whether that's the users or whatever else, whatever other companies or integrations or whatever. And so we have this internal problem where we can't anticipate what will happen as a result of the interactions internally. And then we also have the problem externally as our products interact with the market and with users. So we just can't possibly know those things until we get into a production environment. Is anyone familiar? You can put this in the chat with the Rasmussen Triangle. Anyone seen that before? Lots of people showing it, but it basically says that there are those pressures. We need you to do things cheap. We need to minimize our efforts here. And that kind of pushes our system. So this is from that guy who articulated that very well, and you can look it up, but this quote stands just fine on its own. It's becoming so difficult to model our systems, right? So we can have a limited model of that locally to do the things we need to do to run tests or whatever, but we can't really fully assess what the behaviors will be. We just have to get it in production. Yes, someone in the chat, yes, agree with you wholeheartedly. Prod is always different, right? And it's just impossible for us to come up with these truly comprehensive models, because even if we can model everything within our system perfectly, could we model the external behavior of like users and the market? No, of course not. So I'm now going to amend my little speech bubble from earlier, right? Chaos engineering is asking, is this, whatever this action, safe, right? And continuous verification asks, what is safe? Where is the safety boundary? How close are we getting to it? Is it moving over time in production? So we become very curious about how that safety boundary is moving in production. Is our area that we can operate within against that boundary becoming smaller? Is it getting larger, right? So we want to see that movement over time in production. Does that make sense to anyone at all? Maybe, yes, no, I'm going to assume that it does.
Could you repeat that just again? I like just barely grasped it.
Okay. Yes, so chaos engineering asks, is this safe? We already talked about that. Perform some action. Is it safe? Continuous verification is asking what is safe. And we're looking to see how that answer changes over time in production. So we could have this kind of, and Heidi's going to talk about this, so I don't want to steal her thunder, but like we have all of our alerts tuned to the idea that the safety boundary is here for whatever component or system. And as we approach that, we know if we cross that, it will cause us to breach like value chain level SLOs or SLAs. But we know that right here is where we get to the edge of that safety, right? But that margin can change over time. So we could be technically performing the same as we always did, right? The same level of performance, but now that level of performance will have some ripple effect that causes our users to have a bad time, basically. So we want to see that safety boundary and how it's moving over time. Fully grasped? Okay, terrific. Thank you for the prompting. Okay, now you've had enough of me just jibber jabbering on about theory, okay? So let's have Heidi, who actually does things, hop up to the plate and describe some of the practices and give some examples. Yes?
Yep, this is the part where we get a little more practical and concrete here. So this is something that Kat already alluded to, but you guys might be familiar with if you're used to working with production systems, which is you get alerts. And as we discussed before, there's lots of unknowns in complex systems, and the unknowns in those systems become knowns when you get that alert and discover that you had a failure. And after the alert goes off, you know that the failure happened, but the issue isn't always something that you could have foreseen. And as Kat mentioned earlier, you can discern cause and effect after the fact, usually in some sort of incident review or something like that. But when that alert goes off, you're not already aware of exactly what happened. So with chaos engineering and then continuous verification specifically, we can proactively identify the failure modes and your system safety boundaries so we know when we get close. So this helps us, before the alert ever goes off, figure out what that safety boundary is, and then also tuning your existing alerts around your production systems with a little bit more insight into where things might go wrong. So let's talk about a little bit more how to do that. And before we go too deep, there's some prerequisites. This might be obvious, but it's sometimes not, because sometimes your systems are in a more greenfield state and they're not super mature yet. But in order to have helpful alerts around your high volume production system, you have to have some sort of real-time monitoring in place. For Java applications, and especially for Kafka applications, you can use something like Prometheus for metrics along with an alert manager. Or you can use, well, in addition to that, you want to have a dashboard of some sort, either like Grafana, Datadog, New Relic, something like that, so that you're able to monitor your production systems. Hopefully you're already there, because if you have a production system and you have alerts on your production system, it would make sense that you would already have this in place. But without having this in place, it'll be very difficult to gain any value from continuous verification. And you also may not realize that you're getting close to hitting a safety boundary when you're running a verification without monitoring. So the ideal situation would be you can watch your dashboards. If you're starting to see something like high resource usage in somewhere, you can just kill the whole thing, stop, and make sure that you don't cause any damage to other users of that system. For example, in a Kafka cluster, you're going to mess everybody else up who's using that same cluster if you have a shared cluster among multiple applications. So that is the first step. Now we'll talk a little bit more about SLOs, service level objectives, or closely related, and the next step would be SLAs, service level agreements with your customers. So SLOs are usually the starting point for our alerts. When we are looking at this question, we want to first start with what our SLOs even are. Then we want to set up, usually the process goes that we set up alerts around our SLOs when we start getting close to breaching them, so that we can take action, because our customers or downstream application teams would be affected if we breach our SLOs consistently, excuse me. So answering the question of what is safe allows us to have an informed conversation with our customers to renegotiate our SLOs. So even if you're just doing chaos testing and you find out, wow, like the reason we're not meeting our SLOs is because our SLOs are not even safe in the first place. That's obviously a good starting point to go renegotiate those. You probably would be aware of that already, but with continuous verification, you can start getting a better idea of where the safety boundary lies. So let's take a look. There's a few common SLO types. Obviously, I'm a bit biased more toward Kafka applications, but latency, data quality, and accuracy and throughput are kind of just general buckets of types of SLOs that we see commonly. And running chaos experiments allows us to find out if we are in danger of breaching these SLOs. For example, if you have a latency-based SLO, let's say that your SLO is from production to consumption, you have 40 milliseconds in which that message has to be processed. And you inject a small amount of latency, let's say like 5 milliseconds, for example, on the network between your producer and consumer, or somewhere in your system, if you have a REST API or something like that, to just confirm, like, if we add this latency, can we still reach our SLOs? And that's a really good, like, kind of low-hanging fruit, like, first step. But that's specifically for like a latency-based SLO, something that would be a good first test. And then we have other alerts. So on our production systems, we probably will have alerts around resource utilization. And these are not necessarily SLO related alerts, but they clearly affect whether or not we're going to be able to meet our SLO. Continuous verification helps us proactively identify if failure is likely to occur for these reasons as well. For example, if we have a verification or an experiment that sends a large volume of synthetic data through our system, and we're monitoring our Grafana dashboard, we can determine if we're running out of resources. That would be something that would be really obvious while we're running the verification. And then for Kafka systems specifically, we have a large buildup of messages that are getting backed up in the topic. We can get an idea of what that looks like, and if we're going to be at risk of serving stale data to our client apps or downstream apps, or if we're going to potentially lose data due to retention. So that's another area that we can get some more information on. And then for continuous verification specifically, as Kat mentioned, our systems change over time. So it's really helpful to get a regular cadence of running verifications in production, ideally. So this allows us to figure out if there's any new failure modes that we didn't have before, or if our safety margin has drifted. And when verifications are run continuously, we can gather a bunch of historical data that we can use to observe trends or any like changes that have happened over time. And in Kafka and Kafka environment specifically, a really common situation for this is if you start out and at the very beginning of your organization of adopting Kafka, you have one app team using your Kafka cluster, and then over time, there's more adoption of Kafka and other app teams start using the same cluster. Obviously, at some point, you're probably going to want to talk to them about getting a new cluster or having some sort of contract or agreement around usage of that cluster, but sometimes you don't, and it just ramps up really fast, and a whole bunch of apps start using the same cluster. Then you have a bunch of new topics created, way more consumers and producers that are sending requests to that cluster, and your safety margin might change, and your likelihood of failure will increase in that situation. So not only then does that inform you and your app team, but maybe other teams around the company that are also using the cluster, or any SREs or anyone else who's supporting that infrastructure. And then, as we discussed earlier, if you have a throughput-based SLO, to process X number of records per second or something like that. You can use that historical data from running continuous verification to determine if that SLO that you previously agreed to is even going to be attainable given the trajectory of those changes over time. So that's a more sophisticated usage, but definitely like gives you the biggest amount of insight if you're running continuous verification regularly. So now here's another use case, specifically around Kafka again, consumer scaling and rebalancing. So if you've worked with a microservice or a Kafka application that automatically scales in response to increases in traffic, this is a really common situation where for Kafka applications, there's consumer group rebalancing. So new consumers are brought online and the partitions in the topic that you're reading from have to be reassigned every time a consumer joins or leaves the group. Sometimes, especially if you have like a crashing consumer, there's some sort of error thrown and just keeps leaving and rejoining. You can get yourself into a hairy situation where all of a sudden your messages aren't being consumed on the topic. So if this happens just generally in production, you'll get an alert for maybe stalled consumption if you have one set up on your topic, or excuse me, on an alert set up to monitor consumption on your topic. And if you have a big traffic spike, you may not have enough time to take action and remedy the situation before you start losing data or serving stale data. So with consumer group rebalancing, specifically too, you can go look at your dashboards and you may not see the obvious sign of we lost a broker or there's high resource utilization, things that are super obvious to just point out and say that's the problem. So if you run a verification or a chaos experiment that allows you to reproduce this, you can get a rough idea of how much time it will take for the consumer group to catch back up after a rebalancing issue occurs, and then also get an idea of how much topic lag will accumulate in that amount of time. So this can help you tune your alerts if you're able to do this successfully and get a good idea of that threshold so that you don't have noisy alerts going off all the time when the consumers aren't consuming, but also the alert will go off quickly enough that you can actually take action before you get to that point of no return where things get scary and you're probably going to be backlogged for a while. So that is a great situation where having that historical data from continuous verification can be really helpful. So let's talk about a few next steps if you're interested in implementing continuous verification in your organization. So first, we want to identify which complex systems we want to start with. These should really be high volume mission critical systems that are worth taking the time and, as Kat said, sometimes putting in a lot of effort to test and invest in, really, like you're investing in the security of your system. And then you want to find a target to start out with. Like I mentioned, sometimes latency-based verifications or other low-hanging fruit verifications are really easy to just kind of get started, something that's really easy to perform. But you also might want to consider if there's some troublesome areas that you don't actually know why failures are occurring in that situation. Maybe that can give you some more insight into what's going on if you try to create a chaos experiment that will either reproduce or mimic that same problem. And then finally, you want to get a buy-in on safety being a priority in your organization. So if there are other app teams or teams around the company and your management that you need to get investment in and agreement in, people that are going to be affected if you don't do this properly, or if you do just need some help getting started, you really want to have a good dialogue with them and get some buy-in on starting chaos engineering or continuous verification. Yeah, that is a good next step. And then that is what we had for the presentation.
Awesome, Heidi. Thank you for all those examples. I quoted from the chaos engineering book earlier, and I do just want to point out that the Rosenthal and Nora Jones, the authors of the book, worked with O'Reilly to give away free copies for some like short amount of time or something. So right now you can download it for free as opposed to paying the $30 or whatever it is. I can't recall, but yeah, you should get it for free. Yes. And I also saw that, Amitai, am I stealing your thunder by going to the chat for questions?
My thunder. Please go ahead.
Okay. Yes. So there were questions in the chat. Let's go there. Yes. Salim asked, you know what? I think we were at a conference right before the pandemic hit. So I remember those times. But anyway, Salim asks, there's this thing like you must be this tall to use microservices. Would you say that there are prerequisites for doing CV tests? And yes, there are probably several organizations that shouldn't be doing any sort of introduced latency, artificial latency in production anytime soon. So I'll give my answer and then Heidi can give hers. But yeah, there are certainly, if you don't have proper monitoring and observability, or if you're not going to invest in the tooling, like it's a recipe for disaster, right? Because with chaos engineering, you're doing the thing, right? You're going to kill this pod. And that is what it is. You're asking, is it safe to do that? With continuous verification, you are trying to identify the safety boundaries. So you have to have that feedback loop, right? So that the verification, if you are approaching the safety boundary, you have to have enough, whatever, instrumentation, whatever, to understand that you are approaching the boundary and then discontinue the verification. We always want to, if we're investing in these things to make our systems safer, then we don't want to be doing things that make them unsafe, right? So we should always err on the side of safety. So we have to have at least enough information in real time to identify, yep, we're starting to see like these few metrics are going in a bad direction, or the shape of that latency curve, like, you know, we've all seen weird things like this, right? Where it's like normal and then it has like a ball of latency on the end or something. Like you have to have enough information to know like, hey, that curve is going in not a good direction. We're going to shut down the verification and record that as being the safety boundary. Heidi probably has much more practical things to say besides stop when there's a ball of latency at the end.
No, I mean, besides just the technical stuff, like Kat mentioned, like monitoring, obviously like logging on your system. So if you have a system that's not super mature and you already have a lot of production issues that you have a hard time debugging, like this is not going to make it any better. Obviously, you definitely want to have that under control first. And then from just a people perspective, I know there's some organizations where you may or may not already have like the explicit trust of like your management or SRE teams. And if you make them angry or distrustful of you for doing crazy things without communicating that to them properly first, that would probably also make your life worse. So as I said before, like the buy-in part where you actually like explicitly discuss with management, anyone else that might be affected, like what you're planning to do and the benefits you think that you can get from doing this. Not to scare you, but just as a matter between people in your organization, you want to be very much on the same page with them first.
Then the other thing that I'll just reiterate that Heidi already said earlier is that this is an investment of time and energy and resources, right? And so like, I don't think that you should necessarily invest in continuous verification for something that is not mission critical, right? Like Heidi knows I have this hilarious story of an organization that was like, we want to start chaos engineering, a really sophisticated chaos engineering practice, and we're going to start whatever on a system, and they're like not telling me what it is. I'm like, what system? What is it? Jira. We're going to start on Jira. I'm like their own hosted Jira. I'm like, count me out, friends. That is that. I don't know. Like Heidi's trying to be like really generous yesterday, where I'm like, oh God, remember that? She's like, maybe that's their service desk and it is mission critical. No, you should only make this kind of investment, right, for something that is mission critical, because it is an investment to keep up this continuous verification. Yes. Andrew has thoughts and opinions about JIRA. Wonderful. Mike, can you say more about what you mean by tripwires?
Yeah, so just the idea that if you're going to start a test, you want to have the feedbacks to include the running of your tests, right? So if I start something and I start to get a cascade, I want to turn it off, not after my phone starts ringing. And I don't know how much attention, because I've not done continuous verification in a real microservices world. So it's like, how much is that included in the thought process of building these tests?
Yeah, Heidi actually has built functionality around this, but let me see if I get it right before you take the mic away from me, Heidi. But you had conditions to stop the verification or prevent it from running. Number one, the first thing it does, like some sort of dry run checks, like will it even be safe to run this verification at all right now? And then some for, if I were to run the verification right now, would I actually get valid results? Right. So there could be some, if there's some other like weird outage or something like that happening somewhere else, or some sort of constraint, like would it even be valid results for this verification? And then within the verification, you have the things like stop the verification if any of these metrics or some combination of these metrics looks terrible, right? Did I get that right?
Yeah, I mean, definitely you want to look at the context around what's already going on, as Kat mentioned. And then when I was talking about having a pretty like mature system that you're working on, to me, that means like kind of having a good rule of thumb, like when you look at your dashboards, like, you know what a scary value is. And I mean, for those of us who've like monitored those, like you kind of have like a gut feeling like this is a scary value for me to see. If I see this, I'm going to freak out. Or, you know, that's when you, like you mentioned, you might get an alert at some value and you want to figure out what the value is a little bit before that. So there's not an exact science to it, obviously. It requires a little bit of just knowing your system as far as like what normal behavior is and what abnormal behavior is. And when you're first starting out, you may not have an automatically stopping verification or a way to have it, the system itself detect when to stop the verification. It might have to be a manual action on your part while you're watching it run. So obviously, if you start out kind of manually pulling the plug before it goes too far, then you can get a good sense of like where to set the automatic or auto halt threshold, basically, if you start running it continuously. So there's a bit of an evolution there from like doing just manual tests to having it continuously run.
Yes, Heidi's always quick to remind me that it's okay to spend some time in the exploratory phase. Yeah, okay, let's see, other questions? Yes, some comments about security engineering, and yeah, chaos security engineering is definitely a thing. Yes, we appreciate the intuition of the humans in our system, and that's like where you start when Heidi's talking about, oh, we're looking for a system where we want to try this out, or a place where it would make sense to perturb the systems. Those are kind of the questions that you're asking, right? Like, where do people have these bad feelings, nasty feelings? Like, what makes them nervous? What or where are we really reliant on the intuition of experts, right? Where they become sensitized to the safety margin. Those are good places to look to start the continuous verification practice. Gary, hello, Gary. Is there a relationship between approaching boundaries here and liminality, i.e. we're starting to think we're entering a boundary-like area, so we'd better start testing right now before we go too far? Yes, in a word. Yeah, so what I like, I brought up Rasmussen earlier in that triangle, and basically what he says is there's like the safety margin, which is kind of like this, it is kind of the boundary area. And what happens because those other pressures, the economic pressure and the workload pressure, is that we eat up the margin and it gets smaller and smaller, and we lose our sensitivity to entering that margin. So we're now like acclimated to just operating at work in this like stressful way where we just have this like baseline of stress and pressure, and our systems are also stressed. And so a lot of times we're really good at defining like, yeah, after this point, users have a bad time. Like they have a bad time at this point, but we are really bad at defining that margin, right? Where we're in the danger zone, but we haven't, it's not officially an outage. Like I always joke about this time that I started a 90-day outage. I considered it, I got it classified as an outage, it went on for 3 months. But it was because we kept having this near miss, near miss, near miss, near miss. And then when I started charting those near misses, it turns out that they were doubling. They'd happen in clusters, and the next cluster would be twice as big as the last cluster. And the amount of time in between the clusters was reducing by half each time. And so you'd have twice as many near misses and in half the time. And just everyone got used to just operating in a state of stress instead of being like, hey, this is extremely unnatural, right? That we have clusters of these things that are just about doubling. And also, so I declared it an incident, and that a 3-month incident. So there you go. But we don't do that, right? Like we're only concerned about an outage, not just a sustained period of, oh my God, I hate my life, right? Heidi, you have thoughts on that?
No, I just understand I hate my life because everything seems to almost constantly be very close to falling over, feeling not a fun feeling.
Yes, Heidi also knows what a turd of a manager I am and how I do things like that. I'm declaring a 90-day incident. Yes. All right, Artie, yes. Yeah, it happens. If you've read Drift into Failure, it's a great book, and there's this example of a part on an airplane. Okay, and we already know the ending because it's a very famous airplane crash. Okay, but he goes through and he traces kind of the drift of the maintenance schedule for the part that ultimately failed, right? So everyone said, oh, this part bad led to a failure. And Cindy Decker kind of traced the history of the maintenance of that part. So it started out and the manufacturer said, maintenance it every however many flight hours, like air up hours, right? And they were maintaining it at that schedule, and it never really needed the maintenance at that interval. Like it seemed very proactive, right? Like it doesn't need to be whatever lubricated or whatever, it seems fine. So then they switch it into like a more standard bucket, like some maintenance they do just like on your car. Oh, I'm doing the 50,000 mile maintenance or whatever. So they then put it in a bucket with other maintenance. And that still seems to be going fine. Then they do all these things. They switch it from hours to miles or something like that. And it just goes through all of this really long drift until finally you end up with this part that's never failed before, 100% being the cause of this crash. So it looked like, oh, here's this, bam, it wasn't broken until it was, but it actually went through this long period of drift before it finally broke, right? And so that, for me, that's what's so interesting, especially in our systems, that you can't generally see, right? Like I can't go somewhere and like see the part. I have to kind of observe it through all of these interactions. And so for me, that's just super interesting. How are things drifting? Because it looks fine, 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 not fine. And that's why I like looking at the curves of the latency and things like that, because I feel like those are places where you get a tiny hint of, hey, there might be a little not fine brewing here. You know? Yes. Anyway. Like garbage collection. I'm trying to go through the chat.
Talking about the, you know, twice as often and twice as bad sort of thing. It's like, yeah.
Yes. It was not garbage collection. It was, I can't even begin to describe. It was a very weird thing that I was working on. And yes, it's a very weird thing. I don't even think I could begin to describe it without giving away like tons of stuff that's protected by NDA, because every single thing on it was custom, and we see how that worked out. Yes. Okay, so we have a question here. Assuming we have blue-green deployments, would you recommend conducting CV tests in a live prod environment or the standby one, or both? My answer to that is really simple, both. But I don't know if Heidi has other thoughts, because you've actually encountered this, right, Heidi? And you also did stuff on the failover between like the live and hot standby.
I don't know that I can say that I did, but I do think like even if you don't have a full-fledged prod environment, like you have a staging environment, you can start by just testing things on a lower environment, like just to find some really obvious problems. I know that might have been sacrilegious or something, Kat, with the facial expression there, because the idea is to run things in prod, since as we mentioned earlier, like there is no replacement for it. But especially when you're just getting started, you can start on a lower environment, but yes, like long term, you want to be running on both live and the standby prod if you have one.
Yeah, I'm notoriously reckless, which is why Heidi is laughing, but I say both. Yeah, if you can afford it, of course. Always the trick. Any other questions? Okay, Amitai, I'll hand it back to you, my friend.